Okay, to start off this section, section 1.2, we're going to talk about some rules that were for exponents. So here's some rules for exponents. So a couple of things. So say if we have something like this, a to the x multiplied by a to the y. So here we see this number down the bottom are exactly the same. There's an a here and an a here, and then we have two exponents, an x and a y. So if we're ever multiplying two things with exponents, we can write one of the bottom numbers, so the a, and then add the two exponents together, x plus y. And so this a here, well, this is called a base, and this will be the exponent. So if we have the same base, the base here is a, then we can add the exponents like this. The second one is, say if we have the same base, so a to the x, and then we're dividing by a to the y. So we have the same base, different exponents, we're dividing by them. So how we write this is, again, just one base, then we write the top one, which is x, minus the bottom one, which is y. Another property that we're going to need is a negative exponent. So say if we have a to the minus x. So if we see this written, well, this is the same thing as saying 1 over a to the x. So if you have a negative exponent, you put it to the bottom of a fraction like this. So say if this is on the top, we can kind of think of this as a to the minus x just divided by 1, since anything divided by 1 is the same thing. And so what a negative exponent does is, if you're on the top of a fraction, it moves you to the bottom. And just like, so say if we had 1 over a to the minus x, now we have, this is in the bottom, but there's a minus exponent, so it's going to move it to the top of a fraction. So this is going to be a to the x over 1. So what just a negative exponent does is, say if you're in the bottom of a fraction, it moves you to the top. And if you're in the top of a fraction, it moves you to the bottom. And then you get rid of the minus sign once you move. So you have a minus sign on the top, but you don't have one on the bottom. Over here, you have a minus sign on the bottom, but you don't have one on the top. And then another exponent rule, I'm not sure if we'll need this section, but we will need it later on, is that any number raised to the 0 power, this is equal to 1. And I guess the last one, any number just raised to the first power, that's just equal to itself. So here's 5 properties. So these first bit of examples that we'll do are basically just going to use these first 3 properties. So say if we want to simplify something like x to the 3 multiplied by x to the 11 times y squared. So here we just have a bunch of things multiplied to each other, so we can look at these rules over here. Here we see if we have the same base and we're multiplying, then we can write one of those bases and add the exponents. So here we have, here's an x and here's an x. These two things are multiplying, so we can just write 1x and then add these exponents, 3 plus 11, which is 14. But then we still have this y times y squared. Okay, so all we did here is just multiply these first 2 things together, but we still have the y and the y squared. But again, here we have a y and a y, the same base, so we can just add the exponents. So we have x to the 14 times, the exponent of this y is just a 1, so this is 1 plus 2, so y to the 3. So here all we just used was this first rule. Oh, sorry, there's one more property we need to write. So say if we have something like this, x over y to the a. What this happens is then this a goes to the x and this a goes to the y. So we're going to have x to the a over y to the a. And then, one more property that we also are going to need is, say if we have x to the a and this whole thing is raised to another power b, this is going to be equal x to the a times b. So if you raise a power to another power in this form, we multiply these two numbers. So x to the a all raised to the b is x to the a times b. Okay, so let's do another example. Say if we have, let's do x squared y to the minus 3 all over z. And then we can raise this all to the power of 2. So the first thing we're going to do here is we're going to simplify, get rid of this parenthesis. And we see using this power that if we have a parenthesis, stuff on the inside, and there's a power, just every piece on the inside gets the power. So this x squared is going to get the power of 2. So we'll have x squared to the power of 2. This y to the minus 3 gets the power of 2. So y minus 3 is the power of 2. All divided by, and then the z gets the power of 2. Okay, so here we have x squared squared, so like this property. Whenever we have something like that, we just multiply the two powers. So 2 times 2 is 4, so this is going to be x to the 4. Here we have y to the minus 3 to the 2. So minus 3 times 2 is minus 6. So we'll have y to the minus 6. And then the bottom we just have z squared. And then the last thing we can do to simplify this is, here's a y to the minus 6. We said that minus exponents bring things from the top into the bottom. So this is going to be x to the 4 over, so we have a y to the minus 6, so we'll put a y to the positive 6 down here, and then to z squared. Right, and so this would be the most simplified version we can have for this part of this particular problem. Let's do another one of those. So here let's have x to the minus 3, y to the 7, z to the 10. Okay, so we have this, and we want to simplify everything. So the first thing we can do is just get rid of all the, there's a bunch of steps we could start with. Let's start just by getting rid of all the negative exponents. So you see here we have an x to the minus 3. So that's going to go into the bottom. And then this x to the minus 5 is going to go on the top. Let's see, do we really want to do that? Here, let's do something else. So here we have, we had this property on the other page, that if we had x to the a over x to the b, this is going to be x to the a minus b. The property was if we have the same base and we have something divided by something in the same base, we can write it once and then do the top power minus the bottom power. Here, so everything is just multiplying together. So really, one way we can rewrite this problem as just x to the minus 3 over x to the minus 5 times y to the 7 over y to the 10 times z to the 10 over z to the 11. Remember, when we're multiplying fractions, you just multiply everything across. So this would be this piece times this piece times this piece, which is that. And then this piece times this piece times this piece, which is that. And now what we're going to do is just apply this rule in these 3 places right here. So here we have an x and an x, so the same base. We're going to write one base. And then it says you put the top exponent minus the bottom exponent. So the top exponent, which is a minus 3, minus the bottom exponent, which is a minus 5. Okay, so there's the first term. The second one, we have a y and a y, so we're going to have y. The top exponent, which is 7, minus the bottom exponent, which is 10. And here, again, a z and a z. So write one z and do the top exponent, which is 10, minus the bottom exponent, which is 11. So now let's simplify all the stuff going on in the exponents. Here we have minus 3 minus a negative 5. So that's x to the minus 3 plus 5. Here we have y to the 7 minus 10, so y to the minus 3. Here's 10 minus 11, so just z to the minus 1. Okay, so minus 3 plus 5 is 2, so x2, y to the minus 3, and then z to the minus 1. And then now to get rid of the negative exponents, we know a negative exponent brings something from the top into the bottom, so this is going to be an x squared. And this y to the minus 3 is going to go on the bottom, so we'll have y to the positive 3. And this z to the minus 1 is also going to go to the bottom, and then I will have z to the positive 1. Okay, so this would be the answer for this one. Okay, so the next thing we're going to talk about is these things called radical signs. And so when this n number here is a 2, we never put the number here, we just write it without it, and we just write this. This is just, the square root of x. For example, the square root of 16 is equal to 4. So really this is the same thing as when there's a 2 here. But when there is this little number n is a 2, you just don't need to write it. You can write it like this. Anyway, so what this means is whenever you come across these type of problems in this section, if we have this, the nth root of x, this is equal to x to the 1 over n power. And so for the most part, we always want to, if we're given this, we want to convert it into this to continue working. So for example, in these problems, so what we want to do is simplify, so let's do the 4th root of x to the 3, y to the 8. So we want to simplify this. And so the easiest way to simplify this is going to be first converting this the radical sign, so this sign right here with the 4, into this notation. So just parenthesis with an exponent. So this is going to be x to the 3, y to the 8. We have our thing. And now to the 1 over n. So here's our n. Our n is 4, so we're going to do 1 over 4. Okay, so now what we have is, something raised to a power. And on the previous page, when we had all those properties, that means that this 1/4 is going to go here, and this 1/4 is going to go here. So we're going to have x to the 3 to the 1/4, and then y to the 8 to the 1/4. All right, so here we have a power to a power, so we multiply them. So this is going to be x to the 3 times 1/4, and we're going to have y to the 8 times 1/4. Okay, so this 3 times 1/4, we can think of this 3 as just, 3 divided by 1. And then when we multiply fractions, you just multiply across. So 3 times 1, that's 3, so we're going to have x to the 3. And 1 times 4 is just 4, so x to the 3 over 4. And this is a power. And same for this y, we can think of this 8 as just 8 divided by 1. So we're going to have 8 times 1, which is 8. So y to the 8. And then 1 times 4 is just 4. Okay, so we have x to the 3 over 4. And then 8 divided by 4 is just 2. So y to the 2. Okay, so that's how we would simplify this expression and down into this piece right here. Okay, so the next one we're going to do. So we did problems when we were combining just things with exponents together already. Like say one of the first problems we did is we had, something like x squared, y to the 3 over y to the 2. This was a problem that we did in one of the previous examples. So now what we're going to do in this next one is this problem right here. So we'll have, let's do 3x to the 6, y to the 9, multiplied by a 4, x to the 16. So now what we want to do is kind of figure out how do we simplify it to combine something like this together. Well, on the previous page we said whenever we're dealing with these radical symbols, it's always helpful to first get rid of them and put them into the fraction notation. Meaning that, so if we have something like this, we want to write it like this. So here we have a 3rd root, so we want to take our inside piece and then put a 1/3 power. So this is going to be x to the 6, y to the 9. And this piece right here is just going to be x to the 16, 1 over 4. So here this 4 thing turns into a 1 over 4, this 3 turns into a 1 over 3, and this inside piece just goes into the parentheses. Okay, so now we have again, 2 things in here multiplied together. We have a power, so this power goes to both of these pieces. So this piece over here, we're going to have our x to the 6th. That's raised to the 1/3. This y to the 9. That's raised to the 1/3. And so we could start simplifying this one. Here we have an x to the 16 raised to the 1/4. So whenever that happens, we have the power to the power. We can multiply these 2 powers together. So that was one of the properties on the first page that we wrote up. So this one right here, this is going to be x to the 16 times 1 over 4. All right, so now let's start simplifying some more. Here, x to the 6 to the 1/3, we'll do the same thing we did right here. So we're going to have 6 times 1/3. So x to the 6 times 1/3. Here's y to the 9 to the 1/3, so that's y to the 9 times 1/3. And here, 16 times 1/4, that's x to the 16 over 4. Okay, so what does this equal? Here we have x to the 6 times 1/3, so it's x to the 6 over 3. 9 times 1/3, that's 9 over 3. And 16 over 4, that's just 4. Okay, so here we have x to the 6 over 3, so that's x squared. Y to the 9 over 3, that's y to the 3. And then x to the 4. All right, so when we simplify this, it just turns down into this piece right here.